guys, it's ADW and welcome back to our computer where today we're going to be doing a really cool program. This one's a bit on the simpler side and yeah, so I'm actually going to go ahead and explain what we're doing, and just because it takes a little while for stuff to get declared, I'm going to explain that while the computer is doing its thing. And actually, I've talked about this before, and I really like to watch like the flashing lights up here and as the computer's doing its thing. But anyway, so let's talk about what this is. This is a Cipher program. And basically the way that this Cipher program is going to work is that it's going to give us a random number, and we're going to have to encrypt that random number. The computer is going to encrypt the random number as well, and if we get that encrypted random number correct, then it's going to turn off. It doesn't do anything, unfortunately, nothing cool, but it's just going to turn off. Now, ideally, if you were going to be using this sort of program in a more practical sense, you might want to like have that be where you actually start the program, but this kind of takes up a lot of program memory, so maybe not with this computer is it the most practical thing. However, it's still a very cool proof of concept, and we're going to be going over it. So right now it's declaring everything, and then soon enough what we should see is on our display output up there, we should see a random number be created. And it should be coming there any moment now. And like I said, we're going to encrypt it. Now, unfortunately, we can't use multiplication for our encryption program here. So we're going to have to make do with addition, and that also means that our random numbers really aren't the best. Actually, that needs to be off, and that like that, and that like that. And that is the correct answer. I've just encrypted it. Now, this is using the exact same algorithm that I used in, more than a year ago, I did a video where I made just a circuit that would do this exact same thing. This is me actually programming this computer to do that. And one of the things I really want to show off with this is just how being able to, this computer can really do pretty much anything that you want it to, and that's what makes computers really unique devices, right? Because you can program it to not only do this encryption process, but it can also do multiplication. Anyway, so I'm actually going to go ahead and cheat and make sure that I've got the correct combination. So off to on, and then off on. So let's make sure that that's the correct answer that I got. Off to on, off to on, off on. That is correct. All right. So now, as you can see, we need an input, and this is where we actually submit our thing. One of the really nice things about this program is that it actually displays the random number while it's computing, or while it's actually encrypting the number. So you can have some time to yourself to figure out, or rather to encrypt it yourself, if you're probably a little bit faster than the computer. So now it's just going to do some math and make sure that I got the correct answer. And because this is the correct answer, and I checked that it's the correct answer, what we should see is any minute now this program done light should turn on, and we will know that the program is done. Now, the way that this is actually going to, or rather, the way that this should work if I get it wrong is, I probably should have showed this first also, but it will choose a new random number, and then based on that new random number, I have to guess again. And if I have no clue how to get an accurate guess, then I'm just going to be sitting around here for years, and I'm just not going to be able to do anything. So as you can see, we got our program done light, and by the amount of time that took, you can probably tell I don't want to do this again, and instead I kind of want to get straight into talking about how this program works. Like I said, it's a pretty simple program, so yeah, let's head into the program memory. So let's go ahead and start off by talking about how we're going to declare our variables and what sorts of variables we're going to need. Now, like I mentioned earlier, obviously we're going to need to have some branching address, and then within our registers we're also definitely going to need a ROM pointer, like we usually do, so that we can get our variables into memory. we're also going to need an input-output pointer and a pointer to memory. And another interesting thing is that because of just the way that this stuff works, we're actually going to end up needing 2 pointers into memory. Now, if you're counting, you'll notice that that's 5 different things that we're going to need to have in our registers, and we only have 4 registers. So what we're going to need to end up doing is we're going to have one register where stuff's constantly switching off. So what we'll do is we'll have, in our address pointer, we're going to have it constantly switching off the information in that last register between an input-output pointer and a pointer for, a second pointer for memory. With that in mind, we're going to have to just make sure that there's going to be a lot of pointer controlling in this program is what I'm trying to say. Okay, there we go. So let's get into actually programming this thing. Like I said, we're going to need a memory pointer. Alright, we've done this thing like a million times. Move from where register 0 is pointing to register 0. And register 0 should start out by pointing at memory 0, or ROM 0, which is this address. And this should give us a pointer that just points to, memory 0. Now, it's important that we talk about what we have in memory 0 and memory 1 for this program, because we actually have something very interesting in memory 0. In order to get truly random numbers, well, first of all, this program isn't going to actually use truly random numbers. Unfortunately, that would require multiplication to make complex formulas, or rather, formulas that are complex enough that we're going to be able to do this. So, what we have to do instead is we have to just take this number and we need to plug it into a much simpler cipher. If you remember from my video on ciphers and random numbers, one of the way that we get random numbers usually, we plug a seed into a cipher. So, and there's no pattern in the numbers that get outputted. So what's going to happen is that we're going to take this number right here, and we're actually going to subtract a number from it, and that's going to be our new random number. Again, this isn't perfectly random. We would need multiplication to make ciphers that are complicated enough to get truly random numbers, but this is going to be good enough. And our seed is just going to be the previous random number we got. So, still following me, one of the things you're probably going to notice is, hey, if I'm restarting the program and I reset the memory, then I'm not going to have, my seed is always going to be 0 for the first time. And that would be true if we reset the memory. You'll remember that we don't necessarily have to reset the memory every time we restart this program, only the registers. So because of that, I've actually added on this thing right here. And this is going to make it so that you can't reset the memory on this thing. At least not right now. Because you don't want to reset this random number. You don't want whoever's inputting stuff to be able to reset this random number. Because otherwise we're not going to be able to get our next random number, and if someone just works out the combination for the first address, then we're going to be in really big trouble. So yeah, basically that's what I'm trying to get across. That's what this is for, and we can't reset the memory because we can't reset this one. So the second memory is the only other one we're using. This is where we're going to store the encrypted result, or rather the number that the computer gets from encrypting the number. So the user is going to input a number that they've decided is the encrypted number. And then what they're going to do, or what we're going to do, the computer that is it's going to subtract the number that we inputted from the number in this memory address, and if that comes out to 0, then we know that the two are equal, and so we know that whoever inputted that number got the correct response, and so we have to end the program. And that's basically how the entire thing is going to work. So there's going to be 2 steps. First of all, we're going to declare everything. Then at the start of our main loop, we're going to get a new random number by encrypting this number. And then what we're going to do is we're going to move the key into this address. We're going to, encrypt the key, or rather encrypt this number using the key in this address, and then we're going to compare this number in here to the number that got inputted, and if they're equal, then we're going to end the program. If they're not equal, we're going to branch to the start of the loop, and there's going to be a new random number. Okay, I probably should have gone over that in a separate piece, but with that out of the way, now that we know everything we need to declare, we've already declared our first thing, which is our first memory pointer. The second thing we're going to need to declare is going to be the main ROM pointer. And like I said earlier, because we have 5 different variables that we're going to need to edit from the registers at any given time, we're going to need to do a lot of moving this register around. So we're going to start out by incrementing register 1. Register 1 is going to be the register where we're going to store the ROM pointer. And now that that is pointing at the second ROM address, what we're going to do is we're going to move from where register 1 is pointing to register 2. And this is going to be really important because in this address is going to be where we store our branching address. So register 2 is going to be basically where what we're going to plug in for our argument when we branch. Now, we technically don't know what it is yet, but I actually do. So, at least I think I do. I think it's address 7. That's the start of the loop. So we're going to need to put that there. So now that we have, now we have 3 of the registers that we need to have declared. So for the moment, we're just going to move on to the 4th one. Oh, whoops, that's a different instruction. But now we're just going to increment register 1 again, because register 1 is where our pointer is, and we're going to point it at ROM address 3. ROM address 3 is actually the I/O pointer. Now, usually when we make an I/O pointer, what we do is, by the way, I'm going to make this into an I/O pointer right now. Usually what we do when we make an I/O pointer is we just subtract 1 from something that has 0 in it. But because of, like I was talking about earlier, how we have 5 variables, the thing that we're going to replace inside of the program is we're going to be swapping off between an I/O pointer and a second pointer to memory. So that means that we're actually going to need to have a ROM address that is pointing to, the input-output system. So that's where we're going to be first getting that into a register. Later on, like I said, we're going to be replacing this by moving our memory pointer into register. By the way, this should, for all this I should have already done move from where register 1 is pointing to register 3, because that's moving the I/O pointer in. Later on in the program, we're going to be moving stuff into this register, so that means that we need to be able to, when we want to use the I/O again, we want to be able to move the actual address in, and if it's not 0, we can't just decrement it and then it'll go to 0, or rather to -1, and we'll have a pointer. So we actually have to use up a ROM address to get that in. Okay, follow me? Anyway, so now we have all of our variables declared, and it's about time that we talked about our main loop. Now, one of the really important things that we do before we enter the loop that we talked about before is we need to make sure that when we go into the loop, all of our registers are in the same position, because if we don't do that, and we branch back to the start of the loop and we have different registers, then our code can't assume, or rather, we can't know in our code where exactly each register pointer is going to be. So at the start of the position that we branch to, we have to make sure that all of our pointers are pointing at their precise position, or rather correct. So it's very important that after we've gotten our I/O pointer, we need to adjust the main pointer, that is what we have in register 1, for the main loop. And in order to do this, so how do I explain this? We have to think to ourselves when we do this, what is the branching instruction going to require? Because our pointers have to be at the start of the loop pointing at the exact same position that they are at the end of the loop. And our loop always has to end with a branching command. So if our branching command requires our pointers to be in specific positions, say to work out what the Boolean is going to be, or rather the branching condition, if we don't work out what that condition, or rather we don't have the correct pointers to work out what that condition is, we can't do the branching. So with that in mind, you'll remember the way that we're going to figure out, whether or not, or rather, we're going to be branching depending on whether or not this address right here, memory 2, we're going to be branching depending on whether or not it is equal to 0 from subtracting. Now the way that we find out if this is equal to 0 is actually kind of simple, because in 2's complement, if you subtract something, it's just like sending all ones in, like we have right here. And this is just from the end of the last program, by the way, so we only have ones in here, and that's because we decremented stuff. So what's going to happen is that if we decrement a number that isn't 0, it's going to create a carryout somehow, just because we only have ones in it. So if there is a carryout, then we know for a fact that the number in here isn't 0. But if there is no carryout, then we know for a fact that this number is 0, and therefore our person guessed correctly. So what we're going to be doing for our branching instruction is we're going to be taking memory 2, and we're going to be subtracting 1 from it. Now, this is going to mean a few things. First of all, I'm going to need to know that, our memory pointer, sorry, I was heading over to the registers, didn't really need to do that, but we need to make sure that our memory pointer is actually pointing to this memory address 1, because this is the memory address that it's going to be using on that last instruction. So we need to, at the start of the program, register 0 needs to be pointing to this address. Sorry, I just had this really dumb moment where I was trying to figure out like what else I needed to have other than just having memory address 1 point to this register, when I actually didn't need to do any of that, because technically the only thing that we need to have control over is we just need to have that memory address pointing here for the very last instruction, and we can adjust all of the other pointers at the end of the program rather than now. And I was thinking that we would have to do that now, but it's going to be much more convenient for us to just jump in to sorry, I just burped. It's going to be much easier for us to I just said it again, jump into the main program from here, and just not adjust our pointers to where they're going to be at the end of the program, because it's going to actually be more convenient to have them as they are now. So, let's see. I'm trying to look at my notes right here, which are on these signs, and see what I can remember, because I think that the only thing I actually need to do is that, I think all I actually need to do is to adjust, I think I just need to adjust memory 0. I need to increment that so that it's pointing at memory 1, and I think that's all I need to do. I want to be really sure though, because I'm really not sure what I'm doing at this point, and these two notes are really bad, so I had to like actually go back to the world, and that's where I found out what I was just telling you guys. So I'm probably going to need to do that again. Nothing wrong with making mistakes, just don't have everything about this program memorized, and it's okay because it's a hard program to memorize. So I think that just pointer for main loop is a prepare memory pointer. Okay, so this is the one where we're actually preparing, quote unquote, preparing the memory pointer for the main loop. So this is where I'm assuming we're incrementing register 1, which is just like that. And actually at the start of the program, we're going to do something really counterintuitive and subtract 1 from it, because we actually need to have it pointing at memory 0 for the start of the loop, but for the end of the loop, it needs to be pointing elsewhere. And by the way, since this is the start of the loop, we can come in here and we can see that this is in fact address 7. So that's all good, but I do want to just go ahead now and go off camera again, see what exactly we're doing here on this address, probably adjusting the pointer. I'm just not sure, or the main pointer address to the position that it needs to be in for the start of the main program. I'm just not sure where that is right now, so I'm like whether or not to increment it or decrement it, so I'm just going to check to make sure. Alright, it was really simple. It was, in fact, incrementing. I probably could have assumed that, but I just wanted to check to make absolutely sure. Alright, so with that incremented, that means that if we come back here, then the next address that we have after our IO pointer is our public message randomizer, and that is indeed our next step after we decrement at the start of the program, right here. Because now what we have is we have our address pointing at memory sub 0. Now, I think I have done a really bad job of not explaining this, and I've wanted to go over this several times, but the cipher we're using is subtracting a particular number. So, for example, to randomize this number, we're subtracting 199 in binary, at least in the old program. You can use pretty much any prime number you want. It's important that it's prime because prime numbers minimize the number of patterns that you're going to have in it. I use 199 because it has significant bits all the way out to this end, which I think is kind of important for making it truly random, because if you have a really low random number, then it's only the first few bits that are just going to always be changing, and then the bits on the end aren't going to change that much. So I like 199, but if you can just Google a list of primes and then find one you want, /want, and what's it called? Randomize them for that. So I forget exactly what 199 is in binary right now, so I'm going to look that up later, like probably next time I cut, and I'm going to put that into this address right here. But for now, we can come back to the start of the main program, which is up here, over here, yeah, and then this right here, this is where we're going to be doing the actual function. And the function we're going to be using is subtraction. So what we're going to do is to randomize, what we're going to do is we're going to subtract 199 from this number. And to encrypt our message, we're going to subtract our random number from our key. So it's key minus random number in that specific order. And the reason that we do this is that when we come back to our main input, the way that you figure out what the code is, and I've never really explained how I do this exactly, except I think maybe in my original video, but I'm not sure I did the best job of explaining it. I add the number that gets displayed to this number, and the sum of those two numbers has to equal what my key is. And this time, by the way, since all of our ROM is already labeled, I know I've been really neat and organized this time, having quote-unquote comments along that side, and I name what the addresses are. And for my key, I've been using 13. Sometimes I use 8, or sometimes I use 11. I like to keep it a small number, personally. But you can do pretty much any number you want. I'm not sure if there's advantages for having primes like there are for the randomizer, but yeah, so I'm just going to put my 13 in there for now and back up to here. So what we're going to do is for the randomize instruction, we're going to subtract from where register, we're going to subtract what register 1 is pointing to. Right now, because of the increment instruction we did back here, it's pointing to, what's it called, the randomizer number. So we're going to subtract where register 0 is pointing, which is pointing at memory 0. So it's going to be memory 0 minus the randomizer number. And that will give us our new random number. And that's all this instruction right here is doing. This is the subtract instruction. We don't actually use subtract and add instructions much, which is kind of strange, but yeah, this is I think this might be one of the few times we've ever used subtract. Yeah, kind of unusual. Anyway, so now that we have a new random number, what are we going to do with it? Well, our extra pointer is already pointing to the input-output system, so let's just move it straight in there. And we all know how to move stuff. We're going to move from where register 0 is pointing to where register 3 is pointing. And my confidence in what we're doing has, yeah, send the random number to the I/O. Because this is our just newly generated random number that we have got right here, and this instruction is sending it to the input-output system, which is exactly what we want to do. So now that we have that, let's see, what do we do next? Let's look at my notes. Oh, copy memory pointer to register 3. Ah, yes, so this is what I was talking about earlier. We're just going to move from register 0 to register 3, because the next instructions are going to require us to have two a pointer pointing to memory 0 and a pointer pointing to memory 1. And the pointer we're going to have pointing to memory 1 is going to be our register 0. And this is the instruction that is going to increment it pointed at memory 1. We're going to be using this one from here on out for pretty much everything, because after we use the random number, we really don't need it again. And this is the instruction where we increment it. This is why at the start of the program we need to decrement it again to counteract this, so that it's pointing at memory 0 for the start of the program. So with that out of the way, what we're going to do is, now that we've incremented that and it's pointing at so now register 3 is pointing at memory 0, and register 0 is pointing at register 1. So now that we know that, what we're going to do is, first of all, we're going to actually increment our main pointer, right? So the reason for this is that we need a new number. And if we come back here, you saw that the key was the number immediately following the randomizer. So if we increment that pointer, it's going to go from randomizer to key. So the key is actually going to be the last thing that we're going to use. And the reason we're going to use it, or rather the reason we're incrementing this, is we're going to move the key into memory 1. And then the way that, like I said, we're going to calculate, or rather the way that we're going to encrypt, we're encrypting the random number right now, is we're going to take our key and we're going to subtract the random number from it. So now that we have memory 1 pointing at that address, what we're going to do is we're going to subtract memory 1 from, subtract by the way, using subtract again already, from where register 0 is pointing. And this is going to, again, this is the part where, this is the actual instruction where we encrypt that subtraction bit. Just want to make sure I'm still on track. Move the key to M2. Oh no, that's right. What I need to do first is I need to actually move the key in before I can do stuff with it. I was thinking that I was encoding it first, or I was encrypting it already, but yeah, that's why I was checking, because it's entirely possible I could do stuff like that. So we're actually going to move this to where register 1 is pointing. And with that out of the way, now we actually have the key in memory 1. So now we're actually going to subtract where the randomized number is pointing to, or rather, the random number from that key. So this is where register 3 is pointing. Remember, register 3 is where we stored memory 0 at the start of the program. And we're going to subtract that from where register 0 is pointing. Alright, so we've just encrypted, and just to be clear, yes, we have encrypted that now. I was just saying subtract there, but this is the actual instruction where I encrypt stuff. So now we have the correct response calculated. So next, what we're going to need to do is we're going to need to get a pointer that's going to actually point to the input-output system. Now, our pointer is very far away from there right now, and if you actually do the math, the interesting thing you're going to find is that I believe it's pointing to address like 8 or something. Like if we come back here, we can actually work out where our main pointer is pointing to, because right now it's pointing to this address, right? Because this is where our key is stored. Right now, that is 1s, 2s, 4s, so it's just 1 in the 4s place, so that means that it's, address 4 is where our memory pointer is pointing right now. Now we need to get back to the input-output pointer, which, if you remember, is right here. Now, where is that exactly? Well, it's on memory 2. Well, instead of subtracting 1 from that number twice, what we can actually do is we can shift that number to, we can shift the number in the register, or rather the pointer register, to the left, because 4 shifted to, wait, is it right or left? It's right, my bad. If you shift that to the right, then you're going to wind up with 2, if you shift 4 to the right. So that's what we're going to do right here. And this is, rather than subtracting 1 twice, this is actually a very nice way to get the pointer to where we need it to be pointing. And as you can see right here, it's going to say like just pointer. Yep. So this is basically just making it so that our main pointer again is pointing to the ROM that has the input-output system. So now that, oops, wow, I think that's one of the few times I've ever done that. But now that we have that, what we can do is we can say, all right, we're going to move from where register 1 is pointing, so the input-output pointer, we're going to move the input-output pointer back into register 3. And now that it's back in register 3, what we can do is we can say, all right, we're going to subtract where register 3 is pointing, so that is the input-output system, which is the input that we're giving to the computer, which is what we've encrypted the message to. We're going to subtract that from where register 0 is pointing, which is memory 1. So we're going to subtract the input-output, that is the answer that we're given, from the correct answer. Now, the question is this going to come out to be 0? And if it is, I explained how the pointers worked earlier. If it does turn out to be 0, then we're going to want to stop the program. Otherwise, we're going to want to continue along our merry way. So, the next instruction is going to be adjust our pointers for the main loop. Because if you remember correctly, at the start of the main loop, our, our main pointer had to be pointing at memory, it had to be pointing at the ROM address that contained the randomized number 199, or the randomizer number. So we're going to need to adjust that pointer so that it's pointing that to that. We just need to get this pointer now pointing to what's it called, the same position as it is at the start of the program, which is to the randomizer. So that's what that instruction is about, because we're getting to the end of the loop. So let's see. So where were we? We just got that adjusted. So now pretty much everything's adjusted. So we can actually, at this point, all our pointers are pointing to the right things. So what we're going to do is we're going to subtract 1 from where register 0 is pointing, because register 0 is pointing to memory 1. And like we said, if we decrement it and there is a carryout, then that means that it's not 0. If there is no carryout, then it is 0. So with that, we can do a branching instruction. Finally, here we finally have our branching instruction. And we can say that we're going to use register 2 as our argument, because register 2 is where that, where the address we're going to branch to is stored. And then the last bit is this one bit that says, do we want to invert this or not? Currently this is going to branch if the, there is a carryout. And that is actually exactly what we want to do. We could add this and make it so that it branches if there is no carryout, but we want it to loop around if there is, if there is a carryout, then, like I said, that means that we want to branch to the start of the program. So usually we would invert this, but actually we don't need to, because it's already in the state that we need it to be in. So this is actually the branching instruction done. Now, in theory, this should just restart the entire thing. So the only case that it's ever going to make it past this instruction is if we've gotten a correct response. And if we've gotten a correct response, there's actually one thing we probably want to do before we end the program. And that is we probably want to clear the display. And the reason we don't, or rather we want to clear this display, is that, if you remember back here, this button doesn't work because I shut it off like this, because we don't want to reset the memory, because that will reset the random number and then the entire thing just falls apart. So we're going to, that means that we also can't erase the output, and it's going to be really ugly to just have to look at that random number while when the program's over. So we're actually going to clear the display here. And the way we're going to do this is we're just going to need to move something that is equal to 0 into that display. So the way we're going to do this is we're going to move, alright, let me try to explain this. So we're going to need to find, actually I'm not sure, oh, I know how to do this, okay. So what we're going to need to do is we're going to need to move from somewhere that we have a number equal to 0 to the screen. And the screen is currently where register 3 is pointing to, right? So this part right here, and this part is going to move something into the display. But what? We need to come up with something that is currently equal to 0. So what I came up with just now is register 2, the address that we have our branching condition in, because there is nothing in that address. And if we move from there to the input-output system, then we're just going to get a 0, because it's not pointing anywhere that we have anything. At least I think. No, it's not. There's nothing at this address. So we're going to move from where that address is pointing, and that number is equal to 0, to the display. And that's going to clear the display. And with that out of the way, all we need to do is we just need to end the program with an end program instruction. Alright, so as it turns out, this video is actually way too long, so I'm not actually going to demonstrate the program working, but amazingly, actually when I was originally recording, I showed off this thing, and I managed to get it to work perfectly the first time, and I actually got to show off getting a wrong answer, but that footage is just going to make this video way too much longer. And I trust that you guys all understand already just how this thing works and how if everything we've done, how everything we've done, I should say, leads up to that working correctly if you get an incorrect answer. So yeah, just trust me on that. I'm not going to be able to show it in the video. Hopefully, if you're following along and building some sort of similar program on your own computer, you'll know how to, or rather, it'll work for you, but I haven't been able to show that. I'm just not going to spend any more time showing that. So yeah, I hope you guys have enjoyed, and I'll see you guys next time.